Well, the RA evaluation was closed last night, so he probably got the results and was just crying.
Was he a bad RA?
No, he's fine.
The RA evaluations. If we did nothing, we might have got a free pizza party.
Oh yeah, RA had us do all those.
Did you have to give good ones in order to get the pizza party?
Gotta give a review.
I see.
So I'm freaking trash right now.
My RA is fine.
All right, so let's talk about procedural versus object. Shut up! Procedural versus object-oriented languages. We were supposed to write some stuff up today. What do we got?
Well, they're both different paradigms or sub-paradigms of imperative languages.
Okay, so
I'm working on it.
I
I was watching knitting videos this morning. I'm almost okay. Check Slack.
Well, you don't watch Slack?
You don't watch Slack?
I didn't see anything about knitting on there, but okay.
What?
Mr. Gonzalez needs a new Hawaiian shirt for his cruise over Christmas because his previous one was thrown out post previous trip. So we need somebody. Was Austin asked who knits, and Blaine knits.
I didn't see this conversation.
It was in general.
Do you really know how to do that? Or you just
Check one today.
He didn't say it. I said it. All right. So object-oriented languages versus procedural. Somebody said programming paradigm. There's different programming paradigms. What separates them? How could
Procedural's like top down, object-oriented is more from the bottom up and uses.
Okay, what do you mean bottom up?
Like you build the thing to be used and you can kind of use it and edit it more easily than if you were using a procedural where when it's written you edit one thing, everything that follows it's kind of got to be edited so that it works.
Okay, so is it fair to say that object-oriented languages are modular?
Yeah, that's kind of what I was trying to say.
All right, so the idea is we build this up in terms of pieces. So these guys try to solve problems the ways a human thinks. Let's just leave it at that. So if you were to open up a here, well, just since I've been doing so much stuff with 3D printers recently, you would open up a 3D printer and you look at all the parts. Now, the 3D printer as an entire object, you kind of say, oh, you look at it and say, that looks like a 3D printer-ish thing to me, and you kind of know what it does. It, somehow you get a file to it and it 3D prints it off of some melted plastic stuff, whatever. But when you look at the 3D printer, it's a collection of parts, a collection of modules, right? Now, what are some examples of parts that would be in a 3D printer or any really kind of piece of technology equipment? Are you going to have
Z80 microprocessor.
Okay, so maybe a microprocessor. Okay, but what about, let's go simpler. Are there going to be like some nuts and bolts?
Yeah.
Some washers? What's a washer? What's a washer object? What is that?
A circular metal disc.
Okay. Flat metal disc. Pretty simple, right? Pretty simple, but is it an integral part of some things?
Yeah.
Okay. What about the nuts and bolts? They're gonna, one of the things with these 3D printers is they have to be like structurally sound, right? You don't want them kind of falling over and things like that, and they kind of need to be rigid so that when the thing's printing back and forth, it's not shaking all over the place. So, you got these metal posts, and that's all fancy, but the metal posts are going to do very little unless they're somehow bolted in place, right? And why do we use nuts and bolts rather than like chewing gum or glue? It's sturdier, it's more permanent. We don't have to wait for the glue to dry, that kind of stuff. Could we duct tape them together? Well, probably. Might look a little ghetto, but it's possible you can come up with a solution there. But even then, you feel like a nut and bolt's going to be more a more permanent and undoable solution. Right? If you needed to get to another part, it's kind of nice that you could have it tight and sturdy, but also get it off, so it will go and do other things. Where if you gorilla glued the thing together or wrapped it with 90 layers of duct tape, it might be more of a challenge, right? You know, when you start having to get the Dremel tool out to get duct tape off, you've used too much duct tape. That seems very specific.
I believe you mean blowtorch. In my experience, you can never use too much. Oh, do we have a blowtorch?
We have a butane torch,
Okay.
and now we have a chop saw.
You need to get one of those handheld vertical band saws that you have to hold like this.
Oh, the reciprocating saws? Just chase freshmen around campus? All right, so when you start thinking about things, lots of the objects that we interact with in our daily lives, you know, computers are kind of moving away from, even though we do still have, you know, they are modular. We have our microprocessor, we have our RAM, we have these different pieces, but there's not moving parts anymore. So maybe it's a more complex way of kind of thinking about what I'm talking about here. That's why I'm purposely picking, you know, like Chinese-made 3D printers, where, I mean, we just got a new one from a company called Prusa.
Is it the big one?
No, the big one is we have one of the big ones and two more coming today. But we kind of the famous 3D printer, like the prosumer 3D printers that all these guys online kind of stand behind, is this thing called the Prusa i3 Mark III. And it pretty much is the same bed size, same print size as all those printers we have down there, but it's triple the price. Now, why is it triple the price? If you're printing normal plastic, it's going to print. You probably wouldn't be able to tell the difference between what came off of that, what came off of our Ender 5s. Now, you can probably print some other plastics because the hot end's a little bit different, the extruder's a little bit different, but in the big scheme of things, it's probably like the difference between like a Cadillac and like a used Chevy. You know, where maybe you have a stick shift versus automatic transmission, you have power door locks, you know, quality of life type stuff is on it. But we got one because we wanted to have the experience of having one of them, and we saved some money by going with the kit instead of the assembled one. So the kit's only twice the cost of the Ender 5s. And so it's $750, and it literally comes in a box with like 1,000 parts in it. I'm not exaggerating. Like 1,000 parts. It is not assembled at all. And we have about 14 hours in on it so far, and it's about 60 or 70% together.
Like, is it so granular that you're putting together like the servos?
Yes. Yes, I mean, it is completely, but it's super high quality, and the instructions they give you are amazing, like really good. And this place is in Prague. But here's what now, so this is where the ethics come into this. So we ordered one of these at $750, right? They sent us two. I checked, we were only charged for one.
Wow.
What's the right thing to do?
Well, as long as you don't resell it, you're fine.
Should we contact the company and let them know that they mistakenly sent us a second one?
Yeah, they probably still let you keep it.
They'd probably just tell you. to keep
More
it.
than likely they would, but you're risking that they might not say that. Well, I mean, they could just charge you for a second one.
They sent it as a mistake.
Yeah, I mean, you're right, but they probably don't know because both of them have the exact same order number on it. So they really shipped two of them as if it was one of them.
They could also give you a discount when you send the other one back. Or
Right, and so we did contact them, you know, and figure, you know, you don't want bad mojo, right? You know, it's the right thing to do. Chances are they'll either say just keep it, or you know, if they say, oh, we'll send you a ship back label or whatever, it's like, well, you know, we do have it. We wouldn't mind keeping it. Is it possible we can maybe get a steep discount on the second one if we agree to keep it, and see what happens? Maybe we'll luck out and they'll just say keep it. Who knows? Because it's basically a box of 1,000 nuts and bolts. But it is an interesting ethical question, right? You get something, because all of a sudden now it's the same price as an Ender 5, the printers we already have. And it's supposed to be the Cadillac of 3D printers, but they accidentally sent us 2. The hope is maybe since we're a school, they thought, oh, well, maybe we'll just send them 2 as a present. I don't think that's what went down, but...
Is there a buy one, get one deal on that? You could use the extra parts and extend.
This is the type place where there could be a buy 2, get 1 deal. It goes in. Yeah, they're all about like all the parts are like the top of the top of the top of the line for every part they use, where they don't really focus on price.
Packing slip for sure only says 1.
Yeah. They actually arrive separately with the identical packing slip in each one.
Nice.
So it's like 2 different people at the company fulfilled the order. But whatever, we did the right thing to reach out to them. I haven't heard back, so we'll see what happens. But in any case, getting back to our example here, you have a box of nuts and bolts, and I know after we spend 20 hours or something assembling those things, I'm going to ultimately have a 3D printer. But that guy is conceived in terms of all those little tiny pieces, right? And each one of those pieces has a role. Now, sometimes it's a very specific role where, for instance, it comes with stepper motors, and stepper motors are going to be somewhat limited for the kinds of things you might use them for, but washers you use for all sorts of projects, right? So some things are very modular, very reusable, as you were pointing out, where you might be using it for your one solution, but then you want to be able to take that over to another solution. Okay, so you can go to Home Depot and you can just buy 1,000 washers, because you might want to just have washers in your garage in case you need a washer for something. Where maybe you wouldn't go there and buy 1,000 stepper motors. You might not need those as often, right? But you sometimes you could use those for different projects, though. I mean, they're just more limiting, right? So object-oriented programming kind of takes this in consideration. It says this is how human beings conceive of things. They conceive of things in modules. Yeah.
I guess kind of goes along with the same point of the modularity, but object-oriented languages are more abstracted, so like you can make a class that is more generalized that you can then subclass out or use for multiple different things.
Mm-hmm.
Whereas in a procedural language, you have to make functions that do exactly what you're looking for.
Sure. Yeah, I mean, even just the abstract idea of a screw.
Yeah.
And then you have the M1, M2, M3, M4 screws, different size screws, and some screws have, are Phillips heads, some are flat heads, some are torque, or hex keyed. So the idea is that, you have this basic concept. If I say, I need 3 screws. What does that mean to you? Or if I need 2 batteries. Is that enough information? You kind of know what a battery is. There's an abstract conception to a battery, right? But now you need to know, okay, well, do you need AA, AAA?
Lead acid, lithium.
Yeah, whatever. What kind of batteries do we actually need for this? There was a comedian I saw not that long ago who said, why aren't there any B batteries? There actually are. It does exist. They just never took off for the different size batteries. But it is kind of, there's C batteries, there's D batteries, and we have A batteries. And I doubled and tripled up on the A batteries, but why is there no B battery? So his whole comedy routine was about things like that where, there's some missing piece. The answer is why. Is there a missing piece? I don't know why this popped in my head, but it's related to it in a loose way. All cruise ships don't have a 13th floor.
It just leaves that filled in.
Yeah. Well, no. I mean,
it goes
from 12 to 14. Yeah.
So there is a 13th floor. It's just called 14.
Correct. Yeah. The 13th floor is 14. Right. Yeah. Yeah. So it's like a superstition-based thing, right? But you would think that would maybe be kind of like, maybe on a per company basis or something. Yeah. I mean, I've been on most of probably not most of the world's brands of cruise ships, but definitely most of the brands of cruise ships that sail out of the United States. None of them have a deck 13. They all have a deck 12. They all have a deck 14, which actually says quite a bit about how big these ships are becoming. If you're on a boat that has that many decks.
superstition behind that?
I'm thinking just as unlucky
Yeah.
as 13th to the
13 is an unlucky number.
It's like Friday the 13th is like the unluckiest day.
The 13th is kind of silly.
Yeah, but it's a reality. Okay, so object-oriented languages, modular. This is trying to mimic the way human beings solve problems, and we tend to get granular, but only to a point, right? Like when we conceive of problems, I didn't. When they sent me that box, I didn't open the box and see 1 trillion atoms, right? It's like build your own washers. You're sitting there, you know, creating your isotopes, trying to suck things together. Yeah, so that's not the way it flies. So we conceive of things down to a level. So we need some sort of basics. So these are like our primitive types in our languages, right? We have primitive types that we use for constructing materials, and you know, some things are getting down to the microscopic level for construction. You know, but that's probably not, that's more a specialized type of building as opposed to, or manufacturing as opposed to like, you know, what you're going into Home Depot to buy, you know, that kind of thing. But that kind of captures this idea of object-oriented programming, where procedural programming is kind of raw logic, right? You know, the procedural version of that, you know, that 3D printer wouldn't really look like a 3D printer. It just would happen to solve the problem of 3D printing. But you might even say that you couldn't create a procedural 3D printer, because there's a concept. There's the you know, they all rely on, you know, this Cartesian, you know, XYZ type thing that does rely on certain things being relative to other things. So there is this. There's kind of a baseline minimum where some parts need to be parallel to other parts or perpendicular to other parts, and if it's not like that, it's not going to work. So it might actually be difficult to conceive of a lot of real life things in terms of in real life things procedurally. So we kind of have to fake it. We have to kind of create a representation for an idea, right? Okay. Now, that's not really how human beings think. That's how programmers think. Right? So with procedural languages, we were, as programmers, we were forced to have to figure out a way of representing real life problems in terms of the tools that we had available to us. Human beings solve every problem available to us in terms of the tools that are in our toolbox, right? We've talked about that for years and years and years, and that goes outside of programming, right? Whenever you solve a problem, you know, you think about the tools that are available to you. So for instance, you're thinking about, hey, we're bringing snacks to the tech talk. Austin says, let's make baked potatoes. That is, that was the hand, by the way.
It's better.
That is weird, isn't it?
Gotta be outside the norm.
I can appreciate that, actually. It's kind of a, you know, people bring cookies, or even, I mean, you want to do potatoes, you do potato chips. You don't like do full baked potato bar. No, I mean, I get it. I mean, there's nothing wrong with baked potatoes. It's just not snack food. No, that might be more normal if he brought crickets. Because there are probably some cultures in the world. Actually, there are. What is it? What is it? Thailand? I think in Thailand, there's some of their street food is insects.
Yeah.
Yeah. So I mean,
Chocolate type of cricket.
yeah, crickets might make sense. That is snack food.
I mean, if they smoke it, I'll eat it.
So,
You'll smoke anything?
No, if they smoke
is it? They're expensive?
To buy, like, as a snack.
Is it crickets or is it other kind of insects? I know grasshoppers is a thing.
Let me go on a tangent with that, because there's some story I remember from my childhood, and I don't quite know what it was, but my grandpa got a sucker, and it had a grasshopper leg in it, and he just crunched on it, and I thought it was the funniest thing ever.
Yeah.
It was a real grasshopper leg. I didn't know that at the time.
Was it in there on purpose,
Yeah,
or?
it was like a sucker, and it was a novelty, and it had a grasshopper leg in it, and he thought it was the cool thing. So
Yeah.
he made it, and I thought it was funny, but I didn't know it was real.
That is weird.
Oh, yeah.
Oh, sorry, that was a tangent.
Yeah, these are things.
I mean, when my mom was in Africa, she like told people there like the lotus game, they ate the lotus, like cooked it in their house.
Yeah. Well, so we get the point. So the point is, human beings solve problems. We solve problems in terms of the tools that are in our toolbox. So the more tools that we can have in our toolbox, the better. With procedural languages, we were also limited by our imagination, right? Now, in some ways, that's kind of makes you kind of a specialized programmer. You know, it's someone, if you had the imagination to represent real world things in code logic through structs and kind of fakesy objects to kind of make it work, there's a level of creativity involved there. Object-oriented languages bring a larger group of problem solvers to the table, because now we're going to say that this is what's called a superior problem solving tool, open to more people, right? This Prusa 3D printer is not open to everybody. To be open to everybody, you're going to pay the $1,000 and have them assemble it for you. If you're a do-it-yourselfer, you order the kit and they send you the box of parts. And that is going to have a different level of expertise or different level of whatever to get that involved in it. It's a harder problem to solve. Object-oriented programming languages now allow more people to program computers. Or it allows people who already were programming computers to now utilize a power tool that allows them to take their inventive, it's the stir-fried crickets? We'll just walked crickets. It's like, turn the heat up, they're moving. Is that a soundboard? 22 minutes. Turn the heat up, they're still moving. Okay, so would you say that object-oriented programming languages were a game changer for computer programming? Do we still use procedural languages today?
Yeah, definitely.
Why?
Well, object-oriented languages might enable quick prototyping, but they're not necessarily very performant. And so if you need something that performs really well, you might try and represent your problem in a procedural language.
Okay. So, go ahead.
I'd say there's a time when you use like every tool in your kit, and there's a time when object-oriented languages make more sense to use over procedural and vice versa. Because like Josh said, procedural languages are often more performance based.
Yeah, there's less layers to have to go through, right?
And just they use less resources generally.
Yeah, I mean there's less organization.
Yeah.
You know, so if you're
It's all linear.
Yeah. Well, not even just that. If you're thinking about you're gonna make a lasagna at home or something like that, and you have all of your different parts stored inside of like Tupperware containers, right? To go and get all your individual ingredients while very organized is somewhat time consuming. You have to find the right Tupperware container, you have to open it, you have to take the right amount out, so on and so forth. And but if you just literally had like this bucket of ingredients, right? Or what most of us do, right? We go grocery shopping and we just operate out of the Meyer bag. Right? That's also our Tupperware. When we're done, whatever's left over, you just put back in the bag and throw it in the fridge. And then you're not sure, like you got eight Meyer bags in there. Like, well, which one is what I had last night and which one is the one I had 2 weeks ago? Yeah, how old is that bag?
No.
It's like, I don't think they make bags that look like that anymore. Then you have a problem. So in any case, we could see that even though it's less organized, even though it's less human, having a pile of your ingredients sitting in front of you would be faster because you have quick access to them, right? Cleanup is maybe going to be harder. Storage long term is going to be harder, but you do have a faster approach to the problem. You might need to be more creative with it. You might, because now you have ingredients kind of mixed together, something like that. And, some of the things cook at different rates and that kind of stuff. So at this point, we're kind of stretching the analogy a little bit, but you get the point. With procedural language, there are less layers, which could translate to better performance, but also require a higher level of creativity that may be worth it sometimes. But more often than not, especially as our computers get faster and faster and faster and faster, the idea of an object-oriented language allows us to have to be less creative or redirect our creativity towards more interesting solutions rather than how we want to conceptually organize the players in our application. That we have a washer object, we have a bolt object, so on and so forth. And these guys mean something, and you can use them along with other types of objects. So having said that, we didn't really fill the slide out that well here, but I think we kind of covered out loud the topics of the comparisons of these languages. So it's probably fair to say that object-oriented languages are better. They accomplish the job of allowing a human being to tell a computer what to do better than a procedural language does. That doesn't mean that procedural languages aren't still viable sometimes. We'll call them special case type things. Now, having said that, when we start thinking about the organization or let's say the implementation of an object-oriented language, let's start with the real life example here. All right, so we have a 3D printer object, right? So we're gonna call this object-oriented language implementation. So we're gonna say 3D printer. That's our example. That's our final object, right? Now, what is a 3D printer comprised of? We're not going to go too detailed here, but we're going to say nuts, bolts, washers, and stepper motors, right? And we might say that a stepper motor is actually a collection of servos,
Wires.
belts, wires. Call that good enough for that guy. All right. Now, can we break down a washer anymore? Or at that point, we're just talking about metals, right? Yeah, same thing with bolts, same thing with nuts. These guys are effectively molded metals or, something along those lines. So we'll call those relative primitives, right? You don't go to Home Depot and, buy a part of a washer. Okay, which is fine. So these are the objects that are involved. So to create a 3D printer, and actually I'm going to do this.
They inherit from the metal class.
Yeah. So I'm going to, okay, I mean, we're kind of getting there. So we're going to go with this level here. So for a 3D printer, this guy is conceptualized in terms of nuts, bolts, washers, and stepper motors, let's say. All right. Now, what is an actual... Okay, we'll just jump to another screen here. Let's go with bolt to keep the giggles down. Okay, what is a bolt?
Metal.
Okay, so we've decided this is relatively a primitive, right? Mm-hmm. But is it fair to say, is a bolt an object in the real world? What makes it? How can we confidently say it's an object in the real world? What are the traits of an object in the real world?
It has a size.
Size?
I can buy it from Home Depot.
That's the Chuck Norris joke. He does his grocery shopping at Home Depot.
Tangible.
Okay, so size, they're tangible.
Does that have a purpose?
Do they have to have a purpose? You walked up to an object before and you said, "What the heck is that?" It's still an object. I don't know what I'd use that for. No, they don't necessarily have to have a purpose, but they do have to be a thing, right? Okay, so maybe that's what we mean by tangible. It's you pick it up and this is a thing.
Yeah, that's right.
All right, and this thing might have a size associated with it. Maybe it has a weight associated with it. But all those things ultimately add up to it's a thing. What's the most generic thing you can think of? Give me an example of a generic thing. More generic than a bowl. So a rock. Okay.
A green cube.
A green cube. Okay.
I don't know.
Well, green isn't all that generic. That's kind of a specific version
Can
of
you
a
think
cube.
of anything more generic?
Cube.
My
That didn't take long at all. Don't. So here's our evidence. There is a such thing as stupid questions.
I'd argue that
Everything
a
has
sphere
color.
is more primitive than a cube, because a cube you have to have 6 points. With a sphere you have to have a point and a diameter.
Depends how the sphere is created. In 3D geometry, spheres are usually created with zillions and zillions and zillions of triangles.
It's not math.
Well, okay, true. But is that tangible? Yeah, go ahead. Yeah, so it's hard to conceive of generic objects, right? You mentioned rock. Sure, we view that as being kind of a generic primitive, but even that, we know rocks are composed of sediments that build up different materials, ultimately, whatever. That brings up a funny story. This is just a whole class of stories, but I mean, this is still good stuff. But how many of you know Van Nguyen? So he was in a geology class, and this was a couple years ago. And English is not his first language, right? So he's not super strong with English. And there was a stand-in teacher. I don't know if it was another student or a substitute or whatever, another faculty member, I'm not sure, who was giving this quiz this day. And he walked up to get some clarification on this question. And the question was asking, so the answer to the question was cleavage, which is an actual thing in geology. It's the space between the rocks. Now, it also has other meanings. Well, so he was going up and asking the girl who's giving the test how to spell it. And it just so happened to coincide, I'm guessing whatever the girl was wearing had some indications. So she became very offended by this random guy who doesn't speak English very well walking up and asking her how to spell cleavage. Finally, he gets the point across that this is actually the correct answer for the test, and then it becomes this funny thing. But yeah, that happens. That happens. All right. So the idea here is that as human beings, we can only go so far back before we can no longer conceive of a generic object, yet we know everything is generic. So if we start bringing in our chemistry and biology things into play here, at the end of the day, Yeah, I know we have subatomic particles, right? But let's not go too far into this because I'm going to start losing. You got quarks and some other made-up particles they're still searching for. But we know atoms exist, right? So in our analogy here, we're going to say that everything that is a thing is made up of atoms, right? Is that a fair statement?
Would atoms be comparable to like ones and zeros?
Sure. Yeah, let's say sure. So, but in our world, an atom is the basic building block of matter. Fair enough? We kind of know there's some subatomic things that make up atoms, but we're not going to go there. We're going to say atoms are our baseline. So if we were trying to describe an atom, if we keep kind of going on this screen here and keep kind of breaking this down, that a 3D printer is a collection of nuts, bolts, washers, stepper motors, blah, 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 is it fair to say that nuts are a collection of atoms? Bolts are a collection of atoms? Washers are a collection of atoms? Servos, collection of atoms? And there might be some levels in between too, right? But at the end of the day, at some level, we have a collection of atoms, right? And then we have to say, well, what is an atom? So we're going to say atom is our most primitive building block for our objects, for our things in our world, okay? So if we start conceiving of object-oriented languages, we have something usually called object, and this guy is the base primitive upon which all other objects are built. Now we've seen this, like for example, through like the Java documentation. So if I come into the Java documentation here and I go just do Java string, it'll take us to Java documentation here, and we see that a string inherits from object. If I click on object, we see that object doesn't inherit from anything. We are seeing how the Java object, well, really we're seeing how all object-oriented languages are built, but specifically we see that Java has named their top-level primitive, their version of an atom, is object with a capital O. This guy doesn't come from anything, so they had to conceive of what an object is. If we come down here and look at what they came out with for objects, so an object, it does have a constructor that takes no parameters and ultimately is, let's call it nothingness, whatever. All right. What can an object do? It can clone itself. It can check to see if it's equal to another object by just looking at memory addresses. It can finalize itself, which tells the garbage collector to come and destroy it. I'm done with this object. So everything that is a thing can be garbage collected in Java, and that ability was given to it at the primitive level, at the atomic level. All right, so it doesn't matter how fancy schmancy our objects are that we write in our programming language, we know that they all can be garbage collected because they got that from their parents, parent, their whatever, umpteen grandparent times. Okay? An object can report its class name. It can give you a hash code. It can notify threads. It can notify a bunch of threads. It can give you a string representation of itself. Now keep in mind though, if you're a Java programmer, you maybe commonly use the toString method. You know that every single object that you ever have in Java will have a method called toString. Why? Because it came from object. It is the core of every object we ever create. We know that the string class will have a toString. We know that Bob's made-up class will have a toString because no matter how many layers there are in the middle, the very top of it, we have the object class. And the object class provides us with a toString. Now, we can reinvent what toString means as we get closer and closer to an object, right? But we are guaranteed that all objects have a toString. Make some sense? All right, they can wait for threads, blah, blah, blah. All right, so regardless of whether or not you would come up with the same list. In Java's world, they said, this is what we've conceived of an atom as being. The basic building blocks of all things object types in the language has to have these abilities, because we want every object to, at the very least, be able to participate in this way. Make sense? Now, that's the idea of your top-level object. So if I come back in here, we say an object is our base primitive upon which all other objects are built. Can I give you, so now if we go back to our analogy of atoms, can I give you a bucket of atoms as a human being and tell you to go build me a washer? Tell you to go build me a bolt? Tell you to go build me a 3D printer? Theoretically, yes. Right? Theoretically. That's why we're waiting for the, the Star Trek, dial a dinner thing. That you could just say, I want spaghetti and meatballs, and it just materializes it because it's just put together the atoms equal to, grandma's spaghetti and meatballs, something like that. Okay, but that would not be convenient for a human being. Right? We don't operate at that level. We want widget-sized things that we can work with to accomplish problems. All right? So, the idea is that a box of atoms, while theoretically will let us solve any problem, isn't convenient for human beings. So when we think about object-oriented languages, we're not quite at the baseline yet. An object needs to exist to create the most generic version of our stuff. So at the very least, we can say that everything is an object. Maybe in our language that we're going to start creating next class, we maybe think conceptually that objects, instead of calling them objects, maybe they're called things. That's how we've been talking about them in here, right? We solve all of our problems in terms of a thing or in terms of widgets, however we want to, so you can brainstorm that, decide which one you think is better, or come up with some fancy German word, whatever. And but the reality is that we have to have this base, but we're probably not going to actually solve problems in terms of those bases. We're going to need to have at least one more layer of kind of primitives based on that base. But that base is important to always be able to say that this guy is an object or this guy is a thing. And now you have stuff like rocks, which are things, but they're a little bit more than a generic thing. A rock has some properties that give it its rockness, right? As opposed to a washer, which is also a thing, and it seems just about as useful as a rock, let's say. You can use rocks to kind of wedge things up and whatever, but, so we're going to say these guys have similar primitive uses, but they are distinctly different. If I put a rock in front of you, I put a washer in front of you, every one of us in here could identify between the two. Correct? You wouldn't have to flip a coin. Well, what's a coin, right? We would be able to identify those things. All right, so the farther away from objects we get, the more specific we get. So we're going to have to think about what we're going to call our top level thing. It's unimportant what we put in there because we're not going to get our language to a high enough level where it's going to actually matter there. But then we have to think about what primitives come off of that for building our language. All right, so that makes some sense? All right, so I'm going to give you a reading assignment in the book for next class. I'll look it up here in a second. That assignment is going to bring us up to speed with how do we start an interpreter which represents an object-oriented language. So we're going to be starting a fresh interpreter next class. Questions, comments, concerns, bribes? All right, I will see everybody on Friday.